Well, we have a question here, question 5, excuse me, question 5, the question says, the graphs of the functions f of x and g of x are sketched below. Both graphs of cast the y-axis at -4. One of the points of intersection of the graphs is 1, -8, which is also a returning point of f. The horizontal asymptote g is y equal to -2. Now we're going to do question 5.3. The question says determine the values of x in the interval. Okay. In the previous videos, we did question 5.1 through 5.1 and then 5.2. Now we're going to do question 5.3. The question says determine the values of x in the interval x is lesser than or equal to 1, for which g of x is greater than or equal to f of x. All right, so I'm gonna move first. Okay, we can just do it over here. So we need the values of x in the interval x lesser than 1, for which g of x is greater than or equal to f of x. We can use the graph to answer this question. Let's see where g of x is greater than f of x. We can see that g of x is greater than f of x in this part, okay, in this portion here. This is the part where g of x is more than g of x in the interval x is lesser than 1, okay, because it's also greater than over this part, but this is beyond the interval x lesser than 1, so it cannot be there. So it is in this portion, so this and that. Basically, we will say that over here the answer will be in this interval 0, because 0 is step from the origin, this point here 0 and then 1 there. So it's going to be 0 lesser than or equal to 1, actually 0 less than or equal to x and lesser than 1. And then let's see now question 5.4. The question says, I'm gonna highlight this question 5.4 here. The question says, write down an equation for determine the values of k for which f of x is equal to k has 2 unequal positive roots. So determine the values of k for which f of x equal to k has 2 unequal positive roots. All right. Now over here, I prefer to do it here next to the graph. Okay, we have like f of x. Excuse me. We have like f of x equal to k. F of x is the parabola. Okay. Well, this simply means that we can write it like f of x minus k equals 0. Now this tells us something. It tells us that the minus k here, okay, tells us it's about a vertical shift. So the same graph can be shifted up or down. Now, we can see that if this graph here, this parabola here is shifted down, okay, if it is shifted up, it's possible also to be shifted up. Okay, let me just draw an illustration here. I'm going to draw an illustration here so we can all see what I mean to say. The graph cuts is like this. It's cutting and then goes up there. Now we want to have to find the value. So actually the vertical shift that will make this parabola to have like 2 positive and equal roots. So here we have like a negative root here and the positive root there. Now there are some possible, if the same graph here, this graph is shifted up, okay, we may have like positive roots over here, there and there. Okay, over here and over there. It was like initially like this. So if we shift, the more we shift up, the more the root also change. Okay, it's moving to the positive, toward the positive. So, okay, the more initially it was this, the more we shift down, we still have negative roots. So meaning we're talking about a vertical shift here, a vertical up. It has to be moved a little bit up, okay, in order to have positive roots. Now, this can happen if k is negative only, because if k is negative, we'll have negative times negative, that will make a positive. Okay, because the graph is shifted up if we add a positive number next to it, and then shifted down vertically still if we minus or add a positive. Actually, if we minus a number, I'm trying to make sense here. I'm saying if we minus, okay, the graph will be shifted up if we add a positive number. It is shifted down if we add a negative number, which means we minus by something, by a positive number. So we can see that if it goes up, this y-intercept here will change. It will get 0 if it is if k has the value of -4. So k must be a value which is lesser than -4. So k must be lesser than -4. K must be lesser than -4. Okay, and it must be more than this value here. The lowest value is -8. So it must be more than that. It must be more than -8 in order to have like a vertical shift that will generate 2 positive roots. Okay, and then question 5.5. In 5.5 here, the question says, write down an equation for the axis of symmetry G that has a negative gradient. All right. The parabola here has like two symmetry lines. Okay, 2 symmetry lines. One line comes this way. The symmetry line passes through the asymptotes. Okay, the intersection of the asymptote is here. So one line goes this way, and the other goes the other way. Now, the line that has a negative gradient, as the question says, is the line that decreases. So which has decreases. So we're talking about this line. Wait, just trying to take it. Okay, but I cannot take it alone. So I'm talking about this line. This one has a negative gradient because it's decreasing. The line that has a negative gradient, m lesser than 0. This one, m is greater than 0. Now, we can write these over here. I can just move my board over here. Okay. 5.5. So the line of symmetry is given by, okay, once the line of symmetry, which is y equal to mx, because it's a straight line, mx plus c, and then with the gradients for the line of symmetry is always, it's actually 1 or positive 1 or -1, but because we're talking about the negative gradients, so this will be y equal to negative x plus c. This is the equation of the line of symmetry. Now, when I sub in the values of x and y, note that x and y are just the asymptotes of the graph. Okay, we did find them in the previous video. So in previous questions, we did find that y was equal to -2. I want to show it now. Y was equal to -2, and then x, let's see. X, yes, x is here, the R value. This R, it's -2/3 from the equation. So let's just go back. Okay, because g of x was expressed by x plus r. R here is the vertical asymptote. Okay, R is, we did find that R was equal to -2/3. And then the other Y is given. Here it is -2, the horizontal asymptote. So we can just move on over here. And then sub in the value of -2/3 there for x, -2/3. And then we have like -2 equal to negative that plus c. And that makes what -2 equal to 2/3 plus c. Now we can move the 2/3 over. That makes -2 minus 2/3 equal to c. Now we can just calculate this. We can use a calculator for that. We have like okay, we don't really need to use a calculator. I'm not a calculator fan. So now we divide here, it's like over 1 here. So we can just times here by 3 and times there also by 3. And then this would be -6/3 minus 2/3 equal to c. And then -6 minus 2 makes -8 over, that makes c is equal to -8/3. Therefore, we will have then oh, okay, yes, it's a mistake here. I already found it over here. It's -3/2. I also did the right substitution here, but for some reason I wrote -2/3 here. It's -3/2. Sorry, -3/2. Okay, so R was -3/2. So I think let me just rewrite over here. Now, now that's okay. I think I need to do it over here. So now we first had do not confuse g of x was equal to k over 1 plus r plus d, and then we did find the values of okay, we did find the values of k and r and everything. So we got like k was 3/1 minus 3/2 minus 2. Now, if we need to find, okay, yeah, because we got r to be negative, there 3/2. So now the asymptote is just 3/2, not -3/2. It must be 3/2. That's the formula for the, remember, g of x. The parabola is given by definition. It's like a over x minus p plus q. Okay, so where p and q are the asymptotes. So now let's not confuse here. So the asymptote here is 3/2 and -2. So those are the coordinates. And because we're looking for that straight line, y will be mx plus c. We sub in the value of okay, the gradient is negative, so it's going to be y equal to -x plus c. Okay, and then we sub in the values of y, which is -2, and then the value of x is 3/2. Yes, not -3/2, but 3/2. And then with this negative, it makes that. And now that makes -2. If I move the -3/2 over, that makes plus 3/2 equal to c. So, and this just calculations makes a half. So c is equal to half. Therefore, y will be equal to -x plus a half. Okay, and then the following question is a question, let's see. Question 5.6. The question says the point P is reflected in the line determined in question 5.5 to give the point Q. Write down the coordinates of Q. All right. Well, over here, I do not have a shortcut to get the reflection of P to Q. Okay, I have to explain how it works. Okay, I'm gonna do like the line in question 5.5 is this line we're talking about. The lines that decreasing. Okay, I'm talking about this line. Okay, this is the line where the gradient is negative. Now we need to reflect the point P on this other side. Okay, so it's gonna be like, in other words, like we're gonna find the line that's perpendicular to this line, okay, by passing through the point P in order to find the reflection. Assuming that the reflection is that point somewhere there. Okay, now over here, I'm gonna write it. Let me just write it over here. Then what we had like 5.6. The line in 5.5 was y equal to negative x minus a half. Okay, now to find the line perpendicular to this, because here the gradient is -1, and the perpendicular gradient will be 1. Okay, or because -1 times 1 makes -1. You remember the property, m1 times m2 must be equal to -1. So the perpendicular gradient here must be 1 in order to have a product of -1. So therefore, the other line will be 1x plus c. Now, because we're reflecting the point P is given by the values like 1 and -8. Now we're going to substitute this point over here. So that will be y will be equal to, if I sub in the point, aside the points, y is -8 and then x is 1. So we have like 1 times 1 plus c there, and then that makes -8 equal to 1 plus c. If you move the 1 over, that makes -8 minus 1, and then that makes -9. C is -1. Therefore, the line perpendicular to the symmetric line is y equal to x minus 9. 1x minus 9. So I just write x minus 9. Now that we got the point, we're going to find now the intersection of, because let me draw a rough sketch here. So let's say that line was this, and then the point P somewhere there. Now I need to find the reflection of P to this line. So meaning we need to find that point here, that's Q, the reflection of P. So to do that, first we're going to find a perpendicular line to the symmetric line. Okay, we're gonna find an intersection point here. Let's do it then. The intersection point is when we equate the two equations. We equate this one and that one. So we're going to set x minus 9 equal to -x minus a half. Okay, if I move the -x over, we get 2x, and if I move the -9 over, we get +9 minus a half, and then this makes 2x is equal to, if you calculate this, you're going to get 17 over 2. Now you divide by 2, you got 17 over 4. So this is this point here, the x coordinate of that point. Now we need to find its corresponding y coordinates. So we sub there, that makes -17 over 4 minus 9. We sub it to this, or even that, it will give the same answer. So if we do the calculation here, we will get 36 minus, that makes -19 over 4. Okay, now that we have this point, we cannot use the midpoint formula to get the value of P. Okay, because this is the midpoint. The midpoint is this point here. So when I use the midpoint formula to find the value of Q, so the midpoint is given by xm is equal to x1 plus x2 over 2, and then ym equal to y1 plus y2 over 2. That's the midpoint formula. Now xm is simply this point here. I want to say that point is 17/2. So I'm going to say 17/2 equal to x1, which is the equivalent of p is 1. And then q, we don't know its value, okay? We just call it x and y. So it's going to be like 1 plus xq. I call it like xq/2. And then ym, which is the coordinate of the midpoint, which is 19/4. So that makes 19/4, negative 19/4, I mean, will be equal to y1, which is -8. It was -8, the equivalent of p. So that's -8 plus y2/2. Then 17/4, sorry. Now, if we cross multiply, we're going to get 17. Okay, let's cross multiply. 17/4. That makes 4 times 1 plus xq equal to 34. That makes 4 plus 4xq equal to 34. If we move the 4 over, that makes 4xq will be equal to 30, and then xq will be equal to 30/4, and that makes xq equal to 15/4. So this is the value of q, okay, the exponent of q. And over here, similarly, if we do 4 times, we cross multiply here and there, that makes 4 times that makes -32 plus 4y2 equal to -38. Okay, so if I move the -38 over, we're gonna get 4y2 equal to -38 plus 32, and then that makes 4y squared, 4iq, will be -6, and then yq will be -6/4, which is yq equal to -3/2. So this is the reflection point. So they just give you two marks, probably because there's a trick to calculate that, but this is actually the way we do. So now, first of all, we find the line perpendicular to the symmetric line, okay, and then the line perpendicular to that, and then we find the intersection point, and then we use the midpoint formula to get the value of q. Thank you.